So I'd like to thank you all for coming. I'm really pleased to see you in such a number. I didn't expect so many visitors. And well, I'm really pleased to present today one of my personal projects, which is an academic collaboration between a university in Providence, America, and that university is Brown University, which is the alma mater of Rockefeller, if you didn't know that. And it's basically about interactive web page eye tracking. So I'm not going to bore you with the title anymore. And I know a lot of presenters like to present themselves on the second slide, but in reality, all they want to say, okay, just a second. All they want to say is hi. So hi everybody, thank you for coming. So I'm going to be talking about the vision behind the technology and the technology itself. Well, kinda, because the technology still isn't there yet. Not in the sense that the technology we need to build that isn't there, but we still didn't build that completely. So I'm going to be talking about what has been done so far and what's the vision behind it. So if anybody had journalism in school, they learned about the 5W and 1H. Does anybody know what the 5W 1H means? It's basically the questions that all newspaper articles answer. So those questions are: what, who, when, where, why, and how. So I didn't really know how am I going to introduce you to the story of the vision. So I wanted to research how can I start this presentation and not bore you too much. So I kind of copied newspaper articles. So I'm going to start with what. So do you know where else that those exact same questions were used? Well, I'm going to go sidetrack a bit, but they were used in the Roman Catholic Church to question sinners why and how they sinned. So, but the thing is, it's always used in video gaming as well. So the basic idea behind those questions is to how can we correct the wrongs and how can we actually level up. So this is the vision behind PageGaze. We wanted to question how our user experience is designed today and how can we improve that and how can we level up. So what? Well, how do we interact with technology? How do we interact with the Internet of Things? And then, has it changed over the course of time? Like, if I was giving this exact same talk 70 years ago, would I be talking about different stuff? And then, is it affected by the advancement of technology? Which means, if the technology rapidly advances in the next 10 years, is it going to be totally different? Am I going to be if somebody's actually watching this talk from the future, am I lying now? And then how could it possibly change from the perspective of the present? How can we actually change something that we're so radically used to and not be so drastic? So we kind of want to move in the direction that we want to change everything, but we want it still to be really familiar, and we don't want to learn new interface methods to actually control technology. We don't want to learn new stuff. How can we control technology that we can already use? So how do we interact? Well, the thing is, conveniently. I can answer that in only one word. We always interact conveniently. So from the start of humankind, people interacted conveniently. Before they actually spoke any languages, they didn't interact conveniently, and languages were convenient, and that's why they developed it. Then we started rapidly advancing, and then we entered the computer age, and then The first computer was actually an oscilloscope, if you actually knew that, and it wasn't convenient to enter text, so we actually invented keyboards, so it's convenient to enter text. Then we invented touchscreens because it's more convenient to use touchscreens on our mobile phones than it is to use keyboards, so we're always moving in the direction which is more convenient. Then we have convenience. When I was designing and making these slides and the presentation, I wanted to have a live Q&A tool integrated with the presentation, and I had a problem finding it. But then I discovered that Google Slides actually have that integration and actually have that in their system. So, thing is, with Google Slides, I'm going to be opening a live Q&A session, and it's going to look something like, sorry, the internet connection is really slow for some reason. You can ask questions anytime you want. You can just raise your hand and ask the question, but you're also going to have well, this isn't working, so let's forget that. The internet kind of bogged down. So anytime you want, you can stop me and ask a question. I'll remember where you are, but I'm going to be answering those questions at specific moments in time because they're really interesting questions, and I want to answer them at the right time, because if I answer a question too early, it's not going to be really interesting. So yeah, this just works. You can just go to this link and ask a question, and you can actually see what everybody else asked, and you can vote on the questions up, and I'm always going to see all of the questions asked, so I know which are the most popular ones. And has anybody experienced this in when using their laptops? You can plug a USB, but then you can't plug another one because there's no room, and that's actually not convenience, and that's why there's a standardized dimension that actually separates the two USB hubs in laptops. So this is the direction we're all heading, convenience. This isn't convenient, and we're mostly like this when this happens. Like I have two USB ports, but I can only use one. Why? So the actual science that studies interaction between technology and humans is called Human-Computer Interaction, or HCI, and it actually researches a specific set of fields. Those fields are designing computer interfaces, implementing those interfaces, and evaluating and comparing those interfaces. So it's really simple. But then we have studying human-computer use. How do humans understand computers? So a lot of companies like Google and Microsoft are developing AIs that are trying to understand human needs. But this is actually a research about how humans understand computers. And there's some things that are not really that interesting. This is also part of the research, but I'm not going to trouble you with. You can ask me after the presentation. It's really scientific stuff. So, interaction interfaces. Those are the interfaces we interface with the computers. So, in the beginning, there was something like this. This is actually from Fallout. We had just keyboards and monitors integrated into one, and this is how we interfaced with technology. But then we leveled up, right? The 5W and 1H. And when we leveled up, we had something like this. We have a mouse, we have a keyboard, which is separate from the mouse. We have a separate monitor, which is more convenient, right? Everybody can move their monitor, their mouse, and keyboard around, which is a level up from the terminal interface. And then, well, we had integrated those interfaces into only one device, which is a laptop, which is more convenient when you're traveling. So the advancement of technology is always in the direction of convenience. Everybody tries to make stuff more convenient. And with time, there was an idea that we don't need to use physical buttons. So we developed new interfaces, but that was a long time ago. So now those new interfaces are not actually called interfaces, and they're not really new anymore. So those are actually touchscreens, and most of us actually use touchscreens right now. So this is more convenient. So I'm really repeating the convenience theory because this is really important to remember. We're trying to move in the direction of convenience. And then, with time, those touchscreen interfaces evolved, and we have still experimental interfaces like virtual reality and augmented reality. Now, these interfaces currently aren't so popular. I don't know how many of you can, everybody that has a VR headset, raise your hand, right? There's really few of us. And this was the same situation with touchscreens. When they came out, nobody really had them, only a few people. And then they became mainstream. So this is what I believe is going to happen with VR and AR. And AR is obviously really, really popular. So a lot of us actually heard of this game. There have been negative and positive connotations about this exact same game. This was one of the most recent games that really made AR really, really huge, because there was a study that the majority of the population in America actually used and played Pokemon Go. So the majority of the population in America actually interfaced with technology via AR, and this didn't happen any time before, so this was really unique at that same moment, which is why the game was so popular. So has that really changed? Has the nature of interfaces changed from the integrated terminal keyboard all the way to the AR system? Well, can somebody define change? What does change mean? Can somebody specifically define what does change mean? Well, for different persons, it means different things. And it has never really stopped changing, because from the moment when terminals were introduced, there were people that are tinkering with them and modifying them and customizing them. So they were changing them from the moment they originated. And then, why would it stop changing? Does anybody know why would we settle on one thing and not ask for something that's more convenient? Why would we just stop there? So yeah, it's been changed. It's changing all the time. And how would you like it to change? You can submit answers to the Google Slides link if you want. How do you want interfaces to change? What do you see in the future? Well, they were omnipresent from the dawn of computers. So this was one of the first computers. It's not really, it's a museum exhibit, but this is something that was really similar to how the first computers looked like. And the thing is, do you see any interface here apart from this, which is the museum exhibit stuff? Well, we might not see, but all of these breakers and switches are actually interfaces. So they were there when computers started. So this is something that's developing with the technology of computers from the beginning of time. And then we have the iterations and the interface methods that were actually developed. And the first one was the terminal mainframe interface. Then we had desktop case PCs. And desktop case PCs, I don't mean the modern ones, but the one that lie flat and you usually put a monitor on. So this was one of the iterations, but that wasn't convenient. So we have tower PCs now, which basically stand upright. But then we have the first generation smartphones, which weren't really smart. They were called smartphone because they weren't as dumb as the others. And then we had a few generations. I lost count, but there was a lot of generations. It's really moving really fast. And then we had the current generation smartphones, which are really smart, I guess. My smartphone actually predicts when I need a bus and tells me you should leave right now because you're going to miss the next bus, and the one after that is like 15 minutes. And he's actually really helping me. Like, if I had, he's my personal assistant. So this is smart compared to the old dumb phones. And then we have AR and VR. And what do they help? Their purpose just entertainment and enjoyment? Can I use AR and VR for something else, like at this exact same moment? Or are they gaming interfaces? Well, no. You can use VR and AR to actually reduce the amount of work you do. And to improve is to change, but to be perfect is to change often. So the takeaway from this is there were multiple iterations throughout time. So people actually change interfaces all the time. Everything changes and changes and changes all the time, when we should embrace that change. And if you remember the keynote that Scott Amix actually held, change actually instills fear into people because they fear they're going to lose their jobs. Smartphone assistants actually made a lot of people lose their jobs because we don't need such assistants anymore. We don't have that much personal assistants. Well, I never had a personal assistant, but this is what some of the research companies say, that a lot of secretaries and personal assistants were laid off because we don't need them anymore, because our machines are doing all the work. So there's fear of change. But then we have the archetypes of HCI interfaces. Some things never change. So these are the things that stay the same. We have, on one side, physical interaction, which means I have to touch the hardware. And then on the other side, we have non-physical interaction, which means I don't have to touch the hardware. So, which is really interesting. And non-physical interfaces, one of the key points of non-physical interfaces is that they include VR and AR and are usually experimental tech. People don't use non-physical interfaces that much, and physical interfaces are the keyboard and mouse, touchscreen, and they have some experimental tech. So do you see what's the same in both? Both have experimental tech. Both of these archetypes are changing, still changing and developing. This is really interesting. Are these colors, is there a significant difference from the left part of the picture to the right part of the picture? I mean, the colors are the same. The colors are different, right? But they are still color bars, right? So has the ideology behind this picture changed from the left part to the right one? Has the ideology from the computer interfaces changed from the beginning to the end? Has it radically changed? Well, it comes down, it's different or the same. It's depends on how you look at that. It's a personal thing. You could say that the interface ideology changed, but you could also say that it didn't. So it's a personal thing of how you understand interfaces. So we always want new stuff, right? And we always want to have new stuff and experiment with stuff because it's fun, right? So there's this one fear of losing their jobs, and then there's this because we also want to experiment with new tech, but we don't want to risk our jobs just for the sake of experimenting and having fun. So how can it change? I'm moving to the part where we actually talk about PageGaze and WebGazer. So how can it change? How could I change something that's really kind of convenient right now? Do I want more convenience? What does more convenience mean? And this is actually the main selling product of Apple. They know what you want before you do. So this was the ideology that the late Steve Jobs actually implanted into Apple. So I kind of tried to research, and this project was about knowing what you want before you actually know. So the thing is, we have to go with the flow. We're traveling in the same direction that we have always traveled to. So we're not going to change something to the point where it's not convenient, but we're going to improve on the existing interfaces and actually move with them. So what's the flow? What does it mean to go with the flow? Well, 90% of interfaces actually use one physical part of the body. Can you guess which part that is? Yeah, it's the hand. We use our hands to manipulate our keyboards and mice. And we use our hands to manipulate our touchscreens, right? We're always using our hands. And what if I'm carrying 2 bags? I don't have a kid, but if I'm carrying a kid and a bag, and I just get a really important message, how can I actually take my phone out and look at it? So this is the problem. This is what's disrupting the convenience. It's not convenient to do so. You would have to drop your bag or sit on a bench, put your kid in your lap. So we're trying to correct this. And then this is what I talked about, so I forgot to change this. So and so get to the point, right? No. Do you see anything missing here? Right? It's a really bad picture, but do you see anything missing? Right? It's the eye. But come on, change. This is really creepy. But not this eye. And this eye is sad because it wanted to be featured in this presentation. Not this eye. It's not mind control. So we don't want people to control our minds. And this, well, this eye is also really angry because it didn't get featured. So we all have this eye I'm talking about. It's the human eye. It's the really simple human eye. So we're actually using our times all the time. We're actually using our eyes all the time. I'm going at the street, in the street, and I see a really nice pair of shoes in the window of a store. So I'm actually using and giving information with my eyes, but nothing is collecting that, right? Nothing is actually interfacing with our eyes and actually collecting the information we give out with our eyes. And this, if you actually look at the side of things, when we want to use our laptops and mobile phones, we actually have to invest effort into specifically using our machines. But when we look, we're not actually investing any additional effort. We're just acting natural, right? So why isn't there any technology that like tracks our eyes and then gets information based on that and makes stuff more convenient based on tracking our eyes? Right, isn't that the title of the presentation, Interactive Web Page Eye Tracking? So we're coming to the point. Well, we're replacing, but we're not replacing, we're removing interfaces. We remove the terminal interface. We're trying to remove the keyboard. It's really inefficient to type stuff. When I want to tell something to someone, I'm not going to stand in front of him and send a text or an email. I'm going to talk to him. So using keyboards is actually slowing us down, which is not convenient. And we also have to stop doing this to the mice, because the mice don't really like this. So I'm going to let my colleague talk first. Well, she's not really here. She's a PhD student from the Brown University, which is an American university, and I'm going to let her talk and stay silent for a moment. Can we get audio?
Devices without the need of purchase of additional equipment.
I'll just rewind it. It's really short. I won't bother you too much.
WebPages.js does not require explicit calibration. Instead, it continuously self-calibrates, but WebPages.js does not require explicit calibration. Instead, it continuously self-calibrates by incorporating user interactions such as clicks and cursor movements that normally occur in all websites. WebPages.js uses a regression model to map eye features to screen locations. For every video frame, the pixels that correspond to the user's eyes are detected. Every time a user interaction occurs, WebGazer.js trains its regression model by matching its location on the screen to the corresponding eye pixels. In the absence of any user interactions, the regression model continuously infers the eye gaze locations on the screen in real time. WebGazer.js is developed in pure JavaScript, is open source, and is supported by almost all web browsers. Developers can swap between face and eye detection libraries and different regression models. WebGazer.js can be incorporated in any web page with only a few lines of code and can perform eye tracking immediately with an average error of 100 pixels. WebGazer.js makes eye tracking possible for millions of users and many applications. For example, online newspapers can see what articles the readers are interested in. Search engines can see what results are most relevant to their users. And eye movements can be integrated in online gaming.
So, did somebody actually spot a problem with this? It's not really precise, right? So we have to find a use for eye tracking that's really rough around the edges. So how can we actually use something that's not really precise? Well, it's easy. We can track things that are not really small. We can track large things. So even though this isn't precise, it can actually see that I'm looking in the general direction of the right side of the room, well, the right side of the room or the left one. So this WebGazer is actually the backbone and the back end of PageGaze, which is the technology we're developing. And if you want to learn more about WebGazer specifically, then you can visit this website. It's the Brown University website and the WebGazer page. And the authors of the WebGazer JavaScript library are Alexandra Paputsaki, James Lasky, Aaron Gokaslan, and Jeff Huang. So yeah, and this is the idea of Alexandra Paputsaki, which is a PhD student from the Brown University. So what we decided, well, I have a really interesting question. What about blind people? Well, what about people that do not have their hands? They can't use the keyboard, right? Well, obviously, this is an experimental technology, and with the advancement of technology, we don't want to leave people behind. We don't want to leave disabled people behind. And there's a specific branch of HCI that actually researches disability interfaces. So how can disabled people actually interface with technology? And this is an experimental tech that deals with people that are not disabled. So I don't really have an answer what about blind people, but this isn't the point of this. So hopefully in the coming years we can develop this first for non-disabled person, and then the disability support can come after that. So I don't know what about blind people, but somebody will, hopefully. Hopefully inspired by some of these technologies which are emerging. So moving on, PageGaze, the vision behind PageGaze. So what is PageGaze? I was talking about user experiences and interfaces up until now. So what is the vision behind the technology? So it's gaze tracking, which is not the same as eye tracking. Eye tracking just works, is basic, it's not basic, it's advanced image processing. If you give it an image, it's going to track your eyes on the image, and it's going to track your iris. Gaze tracking is actually projecting eye tracking to a 2D plane. So it's projecting the eye tracking to the screen or monitor or a window in the store or something else, the screen at the movie theater. So this is basically using eye tracking and then moving that onto the screen. So this is kind of builds upon eye tracking, and it's modern. So there's a lot of modern technologies. Usually most of the technologies that appeared recently are modern because they're recent, but that's not really the definition of modern. Modern means it's innovative. It isn't the same as the things that came before it. It's unique, and people won't like it. Being modern means people won't really embrace the change so easily. That's the thing with hipsters in San Francisco. They usually start using a product really soon after it develops. But then the whole world follows along. Europe is actually lacking behind America in modernism, or actually it might not be lacking, it might be specifically trying not to follow the trend. So people in San Francisco actually first started using MacBooks and Apple iPhones because it was modern, and then the rest of America followed, and then a lot of Europe uses iPhones, but a lot of Europe still doesn't. So you can see that Europe is still behind the trend, behind the hip, and this is modern, so some of you might not like it, some of you might like it. It's elegant. So when I talk about technology, how can a technology be elegant? A woman can be elegant. Clothes can be elegant. Design can be elegant, but how can a technology be elegant? It's not physical. Well, elegance means that it appeals to most people. Well, it appeals, and it's sleek. It doesn't have too much bloat. It doesn't have too much stuff that's not really concerned to the core of the project. So this should appeal to most people because it's going to make their life easier, and it doesn't have much except the thing it actually is, so it's really minimalist. It's transparent. What does it mean for technology to be transparent? Like, every technology is transparent, right? You can't see it. No. Transparent technology means that it's really easy to see how it functions. So it's really easy to see behind how it really functions. So can somebody tell me how CPUs actually function at the level of electrical engineering? Raise your hand who can explain that. One, okay. So it's not really transparent. You can actually, you know how the CPU works. It processes information, but most of you don't know how it actually works on the transistor level. So that means it's not transparent. And most of you will understand how PageGaze works, and most of you will understand how it actually does that. Moving on. It's lightweight. Okay, there's not much code in it, more or less. It's in JavaScript, so some of you might be, no. Okay, I'm going to leave the room now. Don't, please. It's in vanilla JavaScript. It was actually developed in a specific JavaScript framework, but halfway along the way, everything just gets thrown in the trash bin, and we developed it from scratch in vanilla. And then it's a modular library, which means you can plug and play different parts of it easily. You can insert a plugin for stores, for computer screens. It has tight integration. We're like, tight integration, what does that mean? Well, tight integration means it functions really well with stuff that already is present. So if I want to make my store automized, I want to make everything that you buy automized. You don't have to go to the cash register. You just pick a pair of shoes and just swipe the card. Well, that doesn't have tight integration, but because there's going to be a lot of work to actually implement that, because of security, because of concerns, because of finding the right size. And this should be the vision, is that it should be really easy to implement. So that means it's tightly integrated with the core of the already present stuff. So I have a question, which is basically, what if I have glasses? So eye tracking is problematic because I'm going to be really honest. The video that Alexandra did was in a really specific and good lighting condition. If I were to try the same thing in this lighting or in the dark, it's not going to be as precise, so it's going to be even less precise. So, but the thing is, it's really experimental. It's going to improve a lot in the coming years. So, yeah, right. It's currently not really usable right now in the real world. You can't actually use that in your stores on your laptop for your everyday work. But it's an experiment to see what's possible and what's going to come in the coming years. And is it a safety threat? I'm going to answer that later because I have a specific slide for that. So, modular design, and from that stems the independent backend thing. So, PageGaze actually works on WebGazer, which is the only JavaScript library that doesn't require explicit calibration before using it, and it doesn't have any third-party dependencies, and it's written in a vanilla JavaScript, and it's really easy to implement. So, PageGaze, so some of you will say, well, you lied. You said it's modular, but then it's tied to a specific component. Well, it actually uses only one thing. It actually uses two things, and both of those things are integer numbers. So it actually uses only two integer numbers from the whole WebGazer library, which is the actual product, which are the coordinates of our eyes projected on the screen. So you can substitute WebGazer with anything else, but there isn't anything else at the moment. So it's kind of forced to use WebGazer. I'm not saying that it's bad. I'm just saying there's no alternative. That's why it's tied to WebGazer. And then it's implementable globally. So implementable globally means I can use it anywhere, right? I can use it to control my air condition. No. It's implementable globally in the sense that developers will understand. So it's implementable on the web using HTML5, CSS3, and JS. And it's implementable on the desktop using the Electron framework, which is GitHub's product. And it's accessible on Windows, Mac, and Linux machines. So this is what implementable globally means in the sense of that developers will understand. So privacy. I'm coming to the safety threat thing. So if somebody tracks our eyes all the time, well, is he invading our privacy, right? Because if somebody is tracking us and tracking what we look at, well, then we don't have privacy. Well, the thing is, privacy is not actually directly connected to tracking. Stuff track a lot of things you don't know. Your cars track the RPM of your engines. So does that mean companies are actually monitoring how you drive? Because the insurance companies can charge you more. Because if you drive recklessly, then the insurance companies can track you. And well, most of the companies don't do that. So even though they're tracking you, they're not invading your privacy because the data isn't sent back to the tracker. It's used for internal purposes. But some insurance companies do. This is really interesting because I've been talking to Scott Amix about this. And his insurance company actually has a really strange device that he puts under his car, and it tracks everything from how he drives to where he drives, so they can charge him more. But then again, he drives really expensive Mercedes. It's a concern, definitely, but only if somebody specifically wants to invade your privacy. So it's not inherently a security threat, but only if somebody builds upon that and invades your privacy, and then you use the product that he has developed, which is kind of what Apple is doing. They're forcing you to use their product and they're tracking you. So this is really a trend, and I'll explain really quick why. Because the best market to be in currently is not hardware, it's not software, it's data. People are selling and buying data. And this is really a really strong trend. Like, people are going to get hardware for free. You're going to go to the store in the next 30 years, and you're just going to pick up the thing you want. So you're just going to take it for free, and you're going to pay with data, with the usage patterns, with what are you doing with it. So this is the privacy concern that we're all worried about, but it's a trend we cannot go against. We can just stay out of the specific field of tracking and invading privacy. We can just hope that someone won't actually use it maliciously. And we have a really strong advantage here because of using JS. JS is client local, which means JS is executed in your browser. So if you don't really want it to send data outside of your browser, you can just disable it from sending data. So you can force it not to invade your privacy, which is really nice. And then the possibilities. What can I do with it? Okay, so I've been talking about user experiences for 40 minutes and I didn't really say what can I do with it. Now, this was general talk. I'm going to be talking kind of specifically to developers now because most of the other people won't understand why this is important. And data analysts will also understand this. Well, better analytics. What does that bring us? This can bring better analytics, but how, why would I want better analytics? I'm not even using it now, right? Well, someone else is, and someone is paying really, really a lot of money to find out stuff. And how come? So we have 3 web page designs here, right? They are really simple. They are wireframeworks of 3 kind of typical web page designs. And some websites are using this one and others are using that one. So a website wants to determine which design is the best for their user base. So one option is to conduct a survey, which nobody will answer. You answer surveys when they say, hey, we have a survey, can we take 5 minutes of your time? Can all the people that actually specifically answer surveys just raise your hand, right? Nobody does that. And it's really a bad way. Then they pay people to take surveys because nobody does. And this is an economic concern because the companies are paying a lot of money because people really don't want to answer surveys. So they hire specific people that are going to then recruit a specific set of people they find on the street to conduct the survey on. It's technically advanced, it's really hard to do, it's time consuming, so we want a better way to do that. But what if we're surveying the user by actually letting him use our website and not actually doing anything specifically? So this is what I was talking about. It's more convenient to actually survey people by letting them not do anything than it is to actually ask them to do something, because nothing is better than something. If I have to worry about one thing, well, isn't it better if I don't have to worry about anything, right? So the user actually decides that this is going to be the interface he likes most by actually looking at it. And then he decides this is the most interesting part of the website, this little square. And then this is the original design, and then the developers can accent the design the user likes and accent the specific sort of content that the user likes. So this, we return to the issue of invading privacy, right? Now I'm sending data, right? And why would I want that? Well, 90% of you are currently sending data to Google and Microsoft and Apple. So 90% of you just sitting in this room, not doing anything, not having your phone with the screen on, you're sending data. Because there's a lot of background services you don't really know about, and you don't have anything explicitly good about that because you don't have any product you're getting from that. But the next iteration of the phone is going to be better for you, so you're kind of paying the next phone by sending data in advance. You're paying for the research of that phone, which is really strange because modern phones cost really a lot. So this is the trend. They're going to cost really low amounts of money because you're going to be paying with data And obviously this is the same model, the business model we're using for PageGaze. And then we have advanced interactive web page design. Oh my god, he's still talking about development stuff. Alright. Well, there's a really long road here, right? So we have a lot to do, and that still isn't done. So what if a website actually has this design that's actually most popular? So we're to the point where we're actually using everything that the user wants. So what now? Well, adaptive elements. How can we actually make elements dynamic? Well, JavaScript does this, but how can we make the elements dynamic in the sense of user interaction? Well, if the user is specifically looking at an article in a blog, we can have a little pop-up that's going to have the whole article. So just by looking at it, we can just open the pop-up. So these are adaptive elements that we don't specifically interact with, but they understand what we want. So if we want to read this article, it's going to pop up. If we want to read the headline, it's going to pop up. So these are adaptive elements, and these are currently not present anywhere. So yeah. Does anybody have any future ideas? What do you think of PageGaze? What do you think that PageGaze should be? Right? Is the city I mean, this is a abstract image. Our city is really going to be looking like this? Is PageGaze really going to be what I'm talking about? Or is this all a lie? So this is currently, I don't even know. I'm working on PageGaze, but I don't know what it's going to be like because it's rapidly changing, adapting to new technologies. So it's still very much in the question. I can't answer my own question. So yeah, I have a question. What does pay with data mean? Well, how to pay with data? Well, the trend is you're going to pay with data by actually using your devices. But are you using your devices right now? I mean, currently, yeah, but the companies still don't have interfaces to use your usage to the top extent. So by advancing interfaces, you can actually increase the amount of money you get from data, which means your usage is going to be worth a lot more to the companies, which means that they are going to charge less for their hardware. And then, what does gazing mean? Well, gazing means looking. This is actually the technology part of the talk, but I have only 10 minutes left, so I'm going to be really quick. Well, gazing, WebGazer uses a regressive JavaScript algorithm. Well, it uses a regressive algorithm implemented in JavaScript to self-calibrate, which means it's self-calibrating. Now, I'm going to be really brief here because I don't know how many of you have experience with eye tracking and specific JavaScript concepts we're working with. So we're using JavaScript to get the coordinates of your PageGaze by using a regressive algorithm, and you can change the algorithm, but this is the main one. It's self-calibrating, which means you don't have to calibrate it before using it. It's standalone, which means it doesn't need any third-party dependencies. And the web page gets, like, I'm really trying to be fast now because I want specific time for end questions. HTML, web page gets, this is how a web page actually looks like underneath the shininess. This is a web page. If you didn't know, I'm presenting this on Google Slides, so this is a web page, and this is actually made out of this. So this is how it looks like on the inside. So we have the coordinates, but we have to correlate those coordinates, which are real-life coordinates, to the actual elements. So this is the second part of PageGaze. We're binding numbers to actually objects. And then we have tagging, where this is a robot tagging a wall with a spray can. So tagging is basically when we find the object that correlates to the coordinates, we're marking it so people can hook it and manipulate it. And then, obviously, yeah. So the thing is, it uses this this stack of technologies. So this is really important. This thing. What? So these are different technologies, right? They were developed aside from each other, but they are always used together. Why? Well, it's the same reason. We have a lot of people working on the same development team. They come from different backgrounds, they come from different companies, and they are working on the same team. Why? Well, because they're a team. They're really better when used together than alone. So this is the problem we have with PageGaze currently. Our team is really small, so people are just thinking, okay, you were talking about technologies, but now, like, no. Okay, so thing is, it's your turn now. We need your help to actually develop that to the point it's actually usable. So I'm inviting all of you to contribute to the development. We're passing the baton. This is a term that's used in the Olympics. We started something, but we came to the point. It's a really small team. It's me and 2 friends. They're developing PageGaze, and WebGazer is developed by 4 people, so it's a really small team for an experimental technology. But we need help. So we're asking for help currently. I'm asking for help. If you're interested in contributing, this is the takeoff I want to say about PageGaze development. Developers aren't specifically productive. A single person can't make much, right? No company actually has a single developer if it's developing something specific. But the thing is that makes products like JavaScript, HTML, and CSS unique because it has a really strong community. And this is what they think that PageGaze needs. We cannot develop it further alone. We need a really strong community around it. So we need you, okay? And this is actually the end of my talk. If you want to test PageGaze in person, you can just ping me and I'm going to explain how to get to the specific conditions where it's actually usable, because it's not usable in all conditions. I'm going to talk about how can you position your laptop so it's actually really good and usable, and what lighting conditions do you need. You can contact me on Twitter. You can open my website, but there isn't anything there. It's just a name holder. I'm squatting on my domain. And you can send me an email. So please send me an email. And I have one more question. I'm shy. What about me? What does that mean? I mean, I'm shy, but what does that mean? You're not interfacing with people, right? You're interfacing with technology. You're shy from technology, right? Can the asker actually raise their hand? I don't really understand the question. So to actually prove that I have this question, because I'm getting blank stares. So I have a question with 4 likes. So can the asker please raise their hand, because I don't really understand the question. You're interfacing with technology, not with people. How can you be shy from technology? Okay. Trolls here, right? So if you have any specific questions you want to answer without actually asking through the Google Slides interface, you can just raise a hand and ask them now. Any questions? Please. Okay, thank you.